So today we are from section 4 group 3. So we are going to present our lab 1 experiment, which is Bernoulli theory. So I am Siti Rahana binti Muhammad Saleh, MA 18119. Basically, Bernoulli principle has been formulated by Daniel Bernoulli in 1783, stated that how the speed of the moving fluid relates to the pressure of the fluid. Okay, so Bernoulli principle is one of the most important principle in the world, and it expresses the relationship between the three important elements that we have learned in fluid mechanics, which are the fluid pressure, velocity, and also the elevation. For the experiment problem statement, student of University Malaysia Pahang, the fluid mechanics subject is required to perform an experiment that uses Venturi meter in order to prove the Bernoulli theorem. A Venturi apparatus is then used to vary the static head and dynamic head. The student required then to investigate the variation of total pressure head, static head, and also the dynamic head.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMED bin Saidi, MA 18158. For our objective, firstly we used to analyze and verify the Bernoulli's theorem experimentally for a thin and incompressible fluid flow, and the second to measure the flow rate, static head, and the total head at all points within the Venturi in the experiment setup. To collect and analyze the data that comes out from the experimental and theoretical results outcome from Bernoulli's theorem. For the scope, while conducting experiment, there are few actions to be taken in order to have obtained a better result of experiment. Firstly, in order to solve the problem of the frictional resistance, we can shortly the distance from the inlet. The action will lead the error to decrease and make the final result will become more accurate. The eye of the observer should be placed parallel to the scale of manometer to get an accurate reading and to solve the problem of marking. We can mark on the manometer tubes and measure the static head when we finish the experiment. The valve should be controlled slowly so that the pressure difference can be maintained.
Hi everyone, my name is Lim Zhen Wei, and now I will continue with the theory part of this experiment. Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. The principle is only applicable for isentropic flows. When the effect of irreversible process like turbulence and non-adiabatic process like heat radiations are small and can be neglected. Bernoulli's principle can be derived from the principle of conservation of energy. These state that in a steady flow, the sum of all forms of energy in a fluid will be the same at all points of that streamline, while all the energy remain constant. An increase in the speed of the fluid will imply there's an increase in the dynamic pressure or kinetic energy. This happens with a simultaneous decrease in the potential energy, including the static pressure and internal energy. Bernoulli's theorem can be generalized to various types of fluid flow, resulting in various forms of Bernoulli's equations. Different types of flow result in different forms of Bernoulli equations. For incompressible flows, Bernoulli's equation in its simpler form is valid. Most liquid flows and gases moving at low Mach number. At higher Mach numbers, more advanced form can be applied to compressible flow. Bernoulli's equations or principle is actually a set of variations on an equation that express the relationship between static pressure, dynamic pressure, and manometric pressure. According to Bernoulli's theory, as a fluid flows at a certain velocity, the pressure surrounding it will decrease. The principal explanations can be seen in these equations. It is the Bernoulli equations. The lowering the fluid pressures in regions where the flow velocity is increased is the qualitative behavior that is commonly referred to as the Bernoulli effect. These equations represent an approximation of the strain velocity and elevations relationship. It holds true in regions of constant, incompressible flow with negligible net frictional forces. There are a lot of applications of Bernoulli's principle that we can find in our daily life. Some of them are venturimeter, aeroplane, carburetor, and the Laval nozzle. Venturimeter is a device that is based on Bernoulli's theorem and is used for measuring the rate of flow of liquid through the pipes. The shape of the wings of an aeroplane is such that the air passes at a higher speed over the upper surface than the lower surface. The difference in airspeed is calculated using Bernoulli's principle to create a difference pressure. The carburetor used in many reciprocating engines contains a venturi to create a region of low pressure to draw fuel into the carburetor and mix it thoroughly with the incoming air. The low pressure in the throat of a venturi can be explained by Bernoulli's principle. In the narrow throat, the air is moving at its fastest speed, and therefore it is at its lowest pressure. The Laval nozzle utilizes Bernoulli's principle to create a force by turning pressure energy generated by the combustions of propellants into velocity. This then generates thrust by ways of Newton's third law of motions.
Assalamualaikum, my name is Syed Kwikmal Irfan bin Tuan Kasmadi. My metric ID is MA18123. So I'm gonna present about method, procedure, and the conclusion. So for the method, here there are two of the lists of the material and equipment. So the list of material, there are three, which are Bernoulli's principal apparatus, hydraulic bench, water tank. So for the list of equipment, there are a lot of equipment that we use in this experiment. So the first one is assembly board, discharge pipe, outlet ball cork, venturi tube with 6 measurement points, compression gland, probe for measuring overall, hose connection, water supply, single water pressure gauge, ball cork at water inlet, 6-volt water pressure gauge, vent valve, drain valve. So this is the method. So we move to the next, which is the procedure of this experiment. So there are 13 steps that we need to do when we conduct this experiment. So step number 1 is the pipe valve, manometer valve, and water flow control valve are ensured to fully open and pipe valve to half open. Second one, the motor pump was started so that the water are overflowing in the manometer valve and single pitot manometer valve in order to expel any air bubbles from both manometer by increasing the speed of water flowing by controlling the water flow valve. So next, the manometer valve and single pilot manometer valve were closed. The pump was stopped and pipe valve 2 was closed simultaneously while pipe valve 1 is remain fully open. So next, manometer valve and single pitot manometer valve were opened carefully to allow the atmospheric air to get into it. So next, manometer and single pitot manometer valve were closed when reached about half of the So next, pitot manometer and manometer valve were reopened. So next step is valve 2 was fully opened and water flow control valve was adjusted so that the position of all level in the manometer were readable starting from tubing 1 until tubing 6. So for the next procedure, all 6 positions of pitot head and static head in the venturi tube were read and recorded by adjusting the pitot tube probe to the desired position 1 to 6. So next step is the data of static head and pitot head reading were recorded and tabulated. The flow rate was determined by recording the timing required to reach the water tank. So next, 5 liters of water using a stopwatch. So the final step is the water flow control valve was adjusted for another 4 flow rates, and step 8 until 11 was repeated and data was collected. So that is from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadli Nadil bin Nashrun. My metric ID is MOINUDDIN. So today I will discussing about chapter 4, result and discussion for experiment 1, which is Bernoulli principle. So this is the formula I've used, which is first I will calculate the volumetric flow by using the second formula, which is the V has been given in the column and 1000 and T is the time, which is 22 seconds. V is the velocity. After I calculated the volume flow rate, I will calculate the volume velocity of the flow based on the point. So this is the formula for dynamic head. This is the formula for measured velocity. So this is also formula for the calculated velocity. This is the formula for dynamic pressure. So we will use this formula in our next step, which is to generate this data. So we can see that this is the data that has been given by our lecturer, our group 3. 5 liters of water taken is 22 seconds. This is the reading of the venturimeter. So we can see that this is the inner diameter for the venturimeter. You can see that the point 3, the inner diameter is the smallest. So we can see that the calculated values here, the static head is 45, which is the lowest with the lowest inner diameter. So this is the table we have generated by calculating by using Excel. Doctor can refer our table in our report later for more detail. So this is the graph that has been generated by using Excel, Microsoft Excel. Static head versus venturi points. We can see that the lowest static head is at the lowest inner diameter. Dynamic head versus venturi points. We can see that the dynamic head is the maximum at the smallest inner diameter of the venturi points. The measured velocity is also at the highest when it is at point 3, which is the smallest inner diameter. The pressure versus venturi points, we can see that the pressure is the highest also at the smallest inner diameter of the venturi points. So for the discussion, from the graph, we can see that the static head is inversely proportional with the inner diameter. The dynamic head will decrease if the inner diameter increase. The measured velocity is inversely proportional with the inner diameter of the venturimeter. The dynamic pressure is inversely proportional with the inner diameter of the venturimeter. So for the measured velocity, we can see that it is according to the continuation formula, which is the smaller the area, the velocity will be increasing. Also for the dynamic pressure, we can see that the dynamic pressure is also at the highest at point 3, as it is the smallest inner diameter in this experiment. So that's all from me. Thank you.
For the conclusion, In this experiment with the measurement of static head, the relationship between the static head and the dynamic head is existing according to Bernoulli's equation. Thus, this experiment justifies the objective for this experiment. Some precautions need to be aware for avoiding the error during taking data from this experiment. So that's it from me. Thank you.